Assalamu alaikum. This is video number 2 for 1.2, which is multimedia. We're going to be going over sound files specifically in this part of this chapter, right? So, first of all, what is sound? So, of course, if you have had physics or even if you're a real human being, right, of course, you know what sound is, right? So, sound is something we hear, right? We speak, other person hears us, that is sound, right? What we speak, a language, other person interprets it, it is doing so because it is hearing us talk through a medium, right? So sound requires a medium in which it can travel. It cannot travel in a vacuum, right? And how is it traveling? It is traveling through oscillations of particle within the medium, such as in real life when we're talking to one another, the medium is air, right? So the air particles oscillate and the other person hears us, right? And the each sound wave has a frequency and a wavelength. This is really important. And the amplitude specifies the loudness of the sound, right? So, if some of you had physics and O levels, so sound was a big thing back then, right? So, you had pitch, you had frequency, you had wavelength, you have loudness. So, you might be aware of these terms, right? So, we're going to be going over that. Okay, so now we have an example of this. This is a pressure wave. So, yeah, it is pressure, time, y-axis is pressure, x-axis is time. Here also y-axis is pressure, x-axis is time, right? So this is a high frequency wave, the period is less, right? So frequency, first of all, if you are aware, frequency is 1 over t, right? So since the time is less, the frequency is more. The time is more, the frequency is less. And the thing about sound is that the sound is an analog value, right? So first of all, to store it inside of a medium inside our computers, we need to turn it into digital sound. Analog sound cannot be stored in a computer, right? So we need to go through an analog to digital converter, which is also known as an ADC. So first of all, to create that, we need to record the sound, right? So that is known as sampling, right? So that is a really important thing. Most of the questions come in this syllabus through sampling rate, sampling resolution. We'll be going over all these three things, right? So first of all, you need to transfer it through the analog to digital converter, right? So it is often filtered first to remove higher frequencies and lower frequencies which are outside the range of human hearing. So when you cannot hear those, right, if you have a music file, right, if it has a very low frequency sound below 20 hertz, it's useless to you, right? If it has a sound above 20,000 hertz, it is useless to you because you cannot just listen to that, right? And then the sound waves are transferred from analog data to digital when they're recorded, and they're sampled at a given time rate, right? The amplitude of the sound wave is measured at intervals and then it is recorded into a digital file, right? So this is an analog sound wave, right? And okay, so something that you need to be aware of is that we're not going to go over this example, but you should just be aware that look at these amplitudes, right? Some of these amplitudes are above the limit, some are below, right? So these amplitudes do not concern us in this term, that we are going to manage them accordingly and then fit them into a digital scale, right? And something that you need to be aware of, that when you are sampling the file, right? So first of all, you need to be aware of what is sampling rate. So sampling rate, sampling resolution, right? So we'll go over these two terms. Okay, so as sampling rate is written here, right? Sampling rate is the number of sound samples taken per second, right? So it is the number of sound samples taken per second. So let us assume we have this wave 1 2 3 4 5 6 7 8 9 10, right? So if you're taking a sample each second, you're recording an amplitude each second, right? So it is obviously going to be more accurate when you compare it to the real one, right? And it is going to be more in size because you're taking a sample each second. But what if you're taking a sample every 2 seconds, right? So if you're taking a sample every 2 seconds, it's not going to be that realistic as compared to the actual sound, but the file size is also going to be less. So there's a trade-off between file size and the accuracy. If you want a very accurate sound, you need to have a better sampling rate, you need to have a very good sampling rate so that you can have a very accurate sound. But in the trade back, you are going to have a higher file size, right? Okay, so what is sampling resolution then? So we just went over sampling rate. It is the number of samples, sound samples taken per second. But what about sampling resolution? Sampling resolution is the number of bits used to encode each sample. So used to encode each sample. So this is what sampling resolution is. So as we just made a wave, right? So you took a sample here, right? So this sample, let us assume it's being stored in 8 bits and 16 bits, right? You have two variations. So of course the 16 bits one, since it is taking more file size, since it's taking more bits, it's going to be more realistic. And of course, as we talked about the trade back, it's going to be more in size. It's going to be more accurate and more in size, right? So how is sampling used to record a sound clip, right? So what exactly is sampling? So sampling is when an amplitude of the sound wave is first determined at set intervals. This gives an approximate representation of the sound wave. The sound wave is then encoded as a series of binary digits. So this is a 3-mark definition that usually comes inside the paper, right? So you just measure the amplitude of the wave at set intervals and then encode it into a series of binary digits. That is indeed what sampling is. And using a higher sampling rate or larger resolution will will result in a more faithful representation of the original sound source. So it's going to be more accurate, right? So what is the pro and con, right? So pro is better sound quality but larger file size. Pro is a larger dynamic range but longer time to transmit. If you're traveling, if you're sending the sound wave, if you're sending the sound file to someone else, since it is a more size, it takes a longer time. So less sound distortion but greater processing power needed to record it and to transmit it, right? Another thing that we'll be going over is that recorded sound is often edited, right? So you edit videos, you edit sound files. So first of all, we need to be aware about what kind of options do we have, right? We can edit the start and stop times. We can extract or delete parts. We can alter the frequency and amplitude, fade in, fade out, mix and merge, combine various sound sources together to create another new sound, sorry. And we can remove background noise, and we can convert between different audio formats. So these are some things that you are provided with the sound editing software, if you are aware of any of those, and if you have used any, or even when you're working with videos, right? So you obviously have a sound section, so you might have encountered these over there, right? And lastly, video is that it is not part of the syllabus anymore, so we'll not go over that.